I want to take a few minutes in just a separate video about the standard deviation and the formula and how the formula works and why it works and what it really measures, because you know the secret to standard deviation and why it works is really just in the math. So I'm going to go ahead and write for you the formula for standard deviation. Okay, now don't let it scare you because I'll explain it to you here in a minute. Standard deviation, which I'm going to write like this, and standard deviation is typically called S, okay, S of x, and that's the way it is on the calculator, is equal to the sum of xi minus x bar squared over n minus 1 with the square root. Okay, so that's the formula, and you're looking at that and saying, oh God, do I have to know that? The answer really is no, you don't, because the formula is going to be on your formula sheet, so you don't have to memorize the formula. What I really want to show you is why it works, because that's really the most important thing and what standard deviation really measures. So let's take a very simple data set. Let's say our numbers in our data set are 1, 3, 5, 7. Okay? Those are our 4 numbers in our data set. So n, the sample size, is going to equal 4. All right? Good. 4. Now, let's figure out x bar. X bar, remember, is the mean or the average. How do you find the average? You add up all the data points. So 1 plus 3 plus 5 plus 7 divided by the number of items. So that's 4. Okay, so this is going to be 16 divided by 4 is equal to 4. So the mean x bar is equal to 4. All right, now let me put this on a number line, okay? Because now we're going to do something really cool. Here's our number line. And I'm going to put a tick mark right here at 4, 3, 1, 5, and 7. So there's 7, there's 5, there's 3, there's 1. Obviously not to scale, but you get the idea. Okay, standard deviation. Look at the words. What does deviation mean? Deviation just means how far away from some place are you? How much does the data set deviate from the mean? And that's what this term right here measures. Let me circle that or put it underlined. That term right there, the xi minus x bar, is the deviation. Let me show you. Xi is just a shorthand way of saying all of the data points. This is x1, this is x2, this is x3, this is x4. So all this equation really says is look at each of your data points, x1, x2, x3, x4, subtract the mean and square it, and then add all those numbers up. Okay, so basically what they're saying is do this. 1 minus 3 squared, 1 minus 4 squared, 3 minus 4 squared, 5 minus 4 squared, 7 minus 4 squared, and then add them all up. Okay, now look at what this is. How do you find the difference of two numbers? How do you find the distance on a number line between two numbers? That's right, you subtract them. So all we're really finding here is the distance between each of these data points and the mean. And here's where mathematicians get cute, okay? If we're looking at the distance between 5 and 4, we just simply subtract them. 5 minus 4, that distance becomes 1. The distance from 7 to 4 is going to be 3, so we know that's 3. Okay, the problem happens when we go the other way. What's the distance between 3 and 4? Well, if we subtract 3 minus 4, this distance becomes negative 1, and the distance between 1 and 4 becomes negative 3. Because you see, we can only subtract it one way in the formula, and in subtracting it one way, all of our data points to the right will have a positive deviation, and all of our data points to the left of the mean will have a negative deviation. What happens if we just added those deviations together? we'd get 0, which would tell us that our deviations on average about the mean is 0, and that's not true. Okay, a 0 deviation means all of our data points are right on the mean, and that's not the case here. So here's what mathematicians do to kind of fool things. We take our deviations and square them. When we square them, that makes all of our deviations positive, right? This one is still 1, this one is still 3, but now this deviation is also 1, and this deviation is 3. When we add all of these up, see, now they're all positives. They don't cancel each other out like they did before. 3, 6, 7, 8. So the adding up of the squared terms here ends up being 8. So for our data set, the sum of the deviations squared is 8. We're going to divide that by n minus 1. Okay? N minus 1 is going to be 3. Okay? Now understand, guys, what we're really doing here is looking at the total squared deviation and dividing them by something that has to do with sample size. Do you see what we did here with the mean? When we found the mean, we added up all of our numbers and divided by something having to do with sample size. So this gave us an average. This kind of gives us an average in a sense too. Even though we're not dividing by n, we're dividing that by something that's based on n. And so the 8/3 can be thought of as an average of the squared deviations. Make sense? Okay, and I guess in some sort of way it does. If we take the square root of things, we take the square root of this average of the squared deviations, we kind of counteract the squared that we did here to make everything positive. And that's an idea or insight into the logic of how standard deviation is computed. Standard deviation is really just, it's like an average of the deviations of the data around the mean. Okay? How far apart or how far away are all your observations from the mean? And let's figure out some way to quantify that. And we do that by taking this, in a sense, average of the deviations around the mean. So we could figure out what square root of 8/3 was and come up with a number. Okay, now later on in the course, in about 3 months or so, we'll actually attach a little bit more meaning to the number that we get with standard deviation. This happens when we talk about the normal distribution. So I hope that gives you a little bit of insight as to why the standard deviation does what it does, why we square things, why we divide by n minus 1. Okay, now, if you are a student of math and you want to be a math or statistics major in college, and you're saying, but wait, why do we divide by n minus 1? Why shouldn't we just divide by n like we did in the mean? Well, there's some good reasons for that. I don't want to tell you on the video because it'll make your brain explode, and most people don't care anyway. So if you have an interest in knowing why, ask me. I'll tell you why.